Hi, my name is Brian Flett. I'm the Senior Director of Energy Solutions at Bentley Systems. We're an engineering software company, and I'm here today to talk to you about leveraging digital twins to pivot your business to clean energy. So there's no question we're at the beginning stage of a massive energy transition. In fact, it may be one of the greatest engineering challenges of our time to move away from sort of carbon-based energy environment to an environment where the majority of our energy can be provided by carbon-neutral sources. That's a major transition, and it's going to involve a lot of work for a lot of players to make this to make this successful. A big part of that is going to be getting a lot more of our energy from electricity, and so electricity generation. We're going to have to generate an awful lot more electricity, and that generation needs to come from carbon neutral sources. If we take a look at the kinds of projects, the kinds of generation projects that are being initiated currently, by far the majority of them are in renewable or carbon neutral technologies. But it's not just electricity. It's not just the electric environment that we need to make fit for purpose for this new world. We need to be able to provide energy from non-electric sources as well. Certainly green hydrogen, the ability to use hydrogen for applications like air travel and things like that, where battery storage just isn't practical. The ability to get heat from the earth and use that to heat homes and businesses through technologies like district heating. All of those are going to be sources of energy that are going to be carbon neutral in the future. And so why would we look to traditional oil and gas companies to make this transition? Why wouldn't we just divert all of our capital to startups in the traditional electric industry? Well, our oil and gas companies have a number of key strengths that they've built over the years that are going to be critical for helping us to make this transition to this new lower carbon world. Oil and gas companies are deep with engineering expertise. They have lots of experience developing complex infrastructure, designing it, building it, operating it, and running the construction projects, the complicated construction projects to build that infrastructure. Oil and gas organizations over the years have been forced to look farther and farther afield for those oil and gas resources, and so they've developed expertise in offshore platforms and deeper platforms in the offshore environment. And that expertise is going to be important when we move to a lower carbon world. More and more of our wind generation, for example, will be through offshore wind turbines. And it's the same sort of issues that you've got to deal with whether it's an offshore wind turbine or whether it's an offshore oil platform. You need to understand the dynamics of the waves, you need to understand the dynamics of the wind, and you need to understand what's underneath the seabed and what you can anchor to, whether it's a fixed or a floating offshore wind farm that you're building. But perhaps the greatest skill that our oil and gas majors and companies have developed over the years is a skill in digitalization, in leveraging digital technologies to be more efficient at all of these engineering processes. In fact, Al Gore, when he talks about the energy transition, he says it's a transition of the magnitude of the Industrial Revolution, but it has to happen at the speed of the digital revolution. And speed is really the essence of the problem here. There's a massive movement that has to happen quite quickly if we're going to avoid fairly significant climate impacts. And the only way to move that quickly is to leverage digital technologies and to leverage the expertise that the oil and gas firms have developed over the years in applying digital technologies to complex engineering projects. And the current sort of state of the art in digital technologies is something called digital twins. Obviously, that's a key aspect of this conference. And if you ask 5 different people for a definition of digital twins, you'll likely get 6 definitions. But this is sort of our definition of what we think of as a digital twin. So a digital twin is a virtual representation of a physical object. It is likely at least two-dimensional, ideally a three-dimensional representation of that object. And it's kept continuously evergreen throughout that asset's life cycle. It includes not just the engineering information, the models and the specs and the diagrams for how that asset is physically configured. It also contains operational information, IoT feeds and SCADA feeds, reality information, maybe coming from LiDAR data or information collected from cameras mounted on drones and things like that. And it contains typical information that you get from your IT systems, your enterprise resource planning systems, your maintenance management systems. All of that kind of information gives you a very rich model of the asset. And not only is it a three-dimensional model, but the real power comes in the fourth dimension, as you can navigate through time and use that model to look backwards, look at history, what's happened throughout the life cycle of that asset, what maintenance has been done, how's the IoT data been trending, but more importantly, look forward. If it's an engineering project, maybe there's some planned engineering work to build new assets or to modify this asset, and you can roll time forward to see what's planned. Or if it's an IoT data stream, maybe you can use the historical information to trend that data stream forward using techniques like AI and things like that to extrapolate what you think and predict what you think the future is going to look like. And then the real power comes from using that model to simulate different possible futures and come up with the best way of operating this asset and of maintaining it and ultimately replacing that asset. And when we think of digital twins, we don't think any one vendor is going to, you're not going to buy your digital twin from one vendor. The digital twin is going to be an ecosystem. And certainly our approach is a very open approach. We support all the major design formats. We support all the major CMS and IoT systems. We've open sourced our underlying technology itself. And we're very involved in international organizations like BRI's Grid Model Data Management Initiative, which are all about ensuring that multiple vendors can communicate with each other and collaborate in providing owner-operators with true digital twins of the operating environment and the operating asset. So let's take a look at how digital twins have been used in some specific examples. This one is a fairly traditional one. It's a traditional oil and gas use of a digital twin. It's Shell, who's using technology that Siemens and Bentley have developed, along with other players like Futuron, and they use it for assessing the ideal configuration of offshore oil platforms. So they've got multiple platforms. They've got an under seabed oil reservoir that they want to be able to extract the oil and gas from, and they can easily configure multiple different or mock up multiple different configurations, and then look at the how those configurations compare, both from a cost perspective, a financial cost perspective, from a environmental perspective, and from a throughput and a benefit perspective. So that's sort of a traditional oil and gas use case of applying a digital twin. And Shell is definitely thinking that that many of the concepts that were developed in the creation of that twin can easily be used for example, offshore wind farms. So very similar problems to be solved. What should the configuration look like? Where should the substations lie? Where are you going to put your cables? How long do the cables need to be? What's the optimal configuration? all of those sorts of questions are very similar for offshore wind farms. In talking about offshore wind farms, it's not just about the design of those farms that you can use digital twins with. We worked with Microsoft and Doosan, who own a wind farm off the coast of South Korea, to develop a digital twin of the operating condition of their wind farm. And so we linked to all their IoT devices through Microsoft's Azure IoT, and surfaced that on top of the digital twin of the farm. And Doosan's able to use that to get a real deep understanding of how their assets are operating, how they're trending over time, and what maintenance and operational tasks they might want to do to make sure that they're getting the throughput from this farm that they had originally planned. And it's not just about throughput and finances. The digital twin can also be used for safety. So, for example, Digital Energy is a company that's built a digital twin on our iTwin platform, and their digital twin is all about surfacing health and safety information on top of this model, and then actually using advanced AI techniques to assess the risk of different areas of the physical plant and be able to create heat maps showing where there are high risk areas based on historical incidents and where maybe their health and safety professionals should be focusing in order to increase the overall safety of the plant. And it's not just safety; it's environmental uses of the twin as well. This example is from China, where another company has built a digital twin on top of our platform, and they're using this to monitor the emissions that are coming from a plant. And the same way you can use your digital twin to evaluate different ways of operating and the financial impact of those operations, you can also evaluate the carbon footprint impact and how different ways of operating your plant or even of configuring your plant can contribute to different levels of a carbon footprint and minimize your carbon footprint. In fact, one organization, One Click LCA, has built a specialized application. Again, it's a digital twin-based application for doing carbon calculations. We're starting to see more standards developing for the best way of measuring carbon and the best way of evaluating your footprint and then minimizing the carbon footprint. In this example, both through the construction, so this is a building that was being constructed, and they were assessing the materials that were being used in the building and the process that were being used in the construction to minimize the carbon footprint during construction. But then even after the facility or the plant is built, you can continue to use these sorts of tools to assess the ongoing carbon footprint of these assets and how to minimize that. So in conclusion, digital twins are a key technology that are going to help us to make this transition to a lower carbon energy environment. They can be used for a variety of things, from optimizing your operations to maximizing asset life, to monitoring your carbon footprint. They can be used throughout the complete life cycle, from design through construction to operations and maintenance. And oil and gas companies have the skills to develop these digital twins and to leverage the technologies to drive engineering innovation, which really is going to be critical for us to make this major transition. And certainly, as said before, it's key that the architecture for these digital twins be an open architecture. It's likely going to be a multi-vendor environment. You're going to have different vendors who have different areas of expertise, and you're going to want to be able to leverage all of that expertise in your digital twin solution. So certainly, as you're thinking about how to go down this road, be sure and look for vendors that are that take an open approach. And the other thing is that the time is to start is now. I do think that oil and gas companies have the expertise to be very successful at this transition. But there's no question that the world is moving forward, and there are lots of startups out there, lots of innovative new companies out there that are moving into this space. And if oil and gas companies want to remain relevant in this new energy world, the time is now to start looking at the investments you need to make from a technology perspective and an engineering perspective to make this major transition. So that's a very quick flyby of how digital twins are currently being used to help energy companies transition to this new energy environment. Certainly welcome any questions that anyone would have on how to get started or our experience in this area.